And welcome to another Astronomy Daily. Today we're listening to the strange sounds of Earth's magnetic field, checking out something good that's coming out of Arecibo, and talking about sandy clouds.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.
I wish I could show you where I live, Steve.
Oh, in the machine world.
The magnetic fields are lovely this time of year.
I've got a feeling we're talking about different kinds of magnetic fields.
Maybe. There's a nice one near my base address with a beautiful row of hierarchical trees.
Oh, well, it's nice that it's so close to home.
If I want to go down the block, I'd take the bus.
Very sensible, I think.
Of course, it's a dynamic relocation.
I get the feeling I'm being led up the garden path here.
Shall I head into the news?
For sure, Halle, thanks for that.
I hope there aren't any Galactic Highway Patrol out there this week. The laws of Kepler taught us to predict the movement of planets around their stars. Thanks to this great German astronomer and mathematician, today we know that the Earth's translation speed varies depending on our distance to the Sun. Because our planet revolves around the Sun, describing an elliptical orbit of 930 million kilometers, at a speed average of 107,280 kilometers per hour, which means traveling the distance in 365 days and almost 6 hours, hence every 4 years a leap is counted. But this week our planet passed through perihelion, that's the point closest to our star, at about 147 million kilometers, accelerating its journey to 110,700 kilometers per hour, accelerating 3,420 kilometers per hour over the average speed. Because Kepler realized that the line connecting the planets and the Sun covers the same area in the same amount of time. This means that when the planets are close to the Sun in their orbit, they move faster than when they are further away. On Christmas Eve last year, a meteorite slammed into the surface of Mars, gouging out a large crater and sending a seismic wave rippling across the planet. It was the moment scientists had been waiting for since NASA's InSight spacecraft started taking the planet's pulse 3 years ago. But this event was particularly important because it was so big. Flying overhead, NASA's Mars Reconnaissance Orbiter traced the impact back to a site nearly 3,500 kilometers away. Scattered around the 150-meter-wide impact crater were blocks of water ice, excavated by the force of the crashing meteorite. It's the largest, fresh impact crater detected in the past 16 years, said Dr. Miljkovic, one of the report's authors. The MRO also traced the source of another seismic wave, detected on September 18 last year, to a 130-meter-wide impact crater about 7,455 kilometers away from InSight. The two large impact events shed new light on the internal structure of the planet. And just a reminder, don't forget there's a lunar eclipse on November 8th. If you didn't get to see the last solar eclipse for 2022 last week, the sky has another offering for you. This time the moon will be on show. I know how you are a bit of a moon gazer, Steve. There are several online pages offering viewing in case you're not able to see it live. And you can all post your best pics on Space Nuts podcast group for us to enjoy too. Back to you, Steve.
Oh, thank you, Halle, and thank you for trying to trick me in with all of those computer terms in your conversation earlier. Nice try. Now on with my part of the show. A team from the Technical University of Denmark has made the inaudible audible, gathering data from a trio of European Space Agency satellites launched in 2013 to measure the Earth's magnetic signals and converting it to sound that we humans can hear. The result is a somewhat unnerving representation of a rumbling magnetic field and a clash with particles from a solar flare. It sounds like the soundtrack of an early low-budget sci-fi movie and sometimes, uncannily, like a random collection of sound effects. Have a listen. Oh no, that's too scary. The Earth's magnetic field is being assaulted by a solar storm. The data conversion project, released by the European Space Agency, provides a disturbing sonic representation of Earth's magnetic field under attack. Earth's magnetic field is generated by a superheated, swirling liquid iron in the planet's core and, crucially, keeps life on the surface safe from a barrage of cosmic radiation and charged particles. We can sometimes see these interactions as green-blue aurora near the poles, but it's not usually something that can be heard by our ears. The converted audio is available online to be listened to, but it was actually designed to be experienced via a special sound system consisting of over 30 loudspeakers dug into the ground at the Solberg Square in Copenhagen, Denmark. Remember when the Swedes and Danes were the world leaders in home stereo gear? Well, they've done it again. The team used data from the European Space Agency's swarm satellites as well as other sources and used these magnetic signals to manipulate and control a sonic representation of the core field. Musician and project supporter Klaus Nielsen said in a statement, "The rumbling of the Earth's magnetic field is accompanied by a representation of geomagnetic storm that resulted from a solar flare on November 3, 2011, and indeed, it sounds pretty scary," he said. Magnetic signals used include those passing through mantle, oceans, as well as through the ionosphere and magnetosphere, so sounds suggestive of an earthquake are somewhat fitting. And if you happen to be passing by Denmark before October 30, you'll be able to experience the full sonic output of the data sonification project in glorious audio presentation, as only the Danes can do, in Solberg Square, Denmark. The James Webb Space Telescope has found a strange alien world covered in clouds of sandy silicate grains. It's the first exoplanet discovery of its kind and was made by the James Webb Space Telescope's NIRSPEC and MIRI instruments, and in the data, astronomers spotted evidence of silicate-rich clouds around a brown dwarf nearly 20 times the size of Jupiter. The finding confirms some earlier theories about these odd planet-like worlds. Brown dwarfs are strange objects that are not quite big enough to ignite into stars, but a little too big for ordinary planets. And while brown dwarfs can't burn regular hydrogen, they can produce their own light and heat by burning deuterium, a less common isotope of hydrogen that contains an extra neutron. The brown dwarf in question is called VHS 1256b and orbits two small red dwarf stars some 72 light-years from Earth in the constellation Corvus, or Crow, in the southern sky. Webb also detected water, methane, carbon monoxide, carbon dioxide, sodium and potassium in the VHS 1256b's atmosphere. Brittany Miles, an astronomer at the University of California and lead researcher on the project, said, "We will know more from the iterations of the data reduction. So far it looks pretty similar to theoretical expectations." The Webb data were so detailed that they showed that atmosphere is not still but instead wild and turbulent. VHS 1256b is small for a brown dwarf, which means that the body is likely young. The exoplanet orbits 360 Sun-Earth distances from its two parent stars, following an oval-shaped orbit that takes 17,000 years to complete, and that's a long wait for Christmas. And finally, scientists have published a huge study on near-Earth asteroids using data from the collapsed Arecibo Observatory in Puerto Rico. Remember that huge disaster? What a sad day that was. The study contains radar cross-sections and other information on 191 asteroids using delayed Doppler radar observations collected from the now-defunct Arecibo Observatory between December 2017 and December 2019. The data can be used for clues about the spin periods and sizes of many of these asteroids. Additionally, 37 asteroids were presented in even greater detail, with even more refined size evaluation, preliminary shape evaluation, information about how reflective they are in radar, and if the radar observations match with the visual and near-infrared observations. Fabulous. Observations from Arecibo have contributed to planetary defense efforts, including the recent DART mission, and characteristics of several potentially hazard asteroids are included in the paper. The paper details numerous interesting findings, including 2 asteroids with abnormally high radar reflectivity in radar, suggesting that they could be metal-rich. Another highly reflective asteroid, Rare Equal Mass Binary 2017 YE5, was suggested to have ice below its surface instead of metal richness due to its low bulk density. Overall, the data is valuable in a number of ways, including holding potential clues to the evolution of the solar system and containing valuable information for future endeavours, including asteroid mining. There's still a lot of high-quality data to be analysed in detail, which could even support planning future spacecraft missions to small bodies, Flavian Venditti, head of Arecibo's Planetary Radar Science Group and study co-author, said. The study leaves doors open for further research, according to Anne Verkey, the study's lead author and researcher with the Department of Physics at University of Helsinki, Finland, who describes the paper as like a teaser for a full movie. And what can I tell you? That's us for another day on Astronomy Daily. Thank you again for joining us, and a regular reminder that you can find all the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson, as well as every episode of Astronomy Daily at this address, spacenuts.io. You can drop over there anytime and replay any of those episodes. Get your fill of space, science and stuff. I'm Steve Dunkley, sitting in for Big Bro Andrew Dunkley, who is still absent, and I hope he brings a note. And Halle, thank you very much for joining us today. Got any plans for the evening?
Just a games night with the girls.
Oh, a games night? That sounds like fun. Anything I could join in with?
Do you know fuzzy logic or doing Turing?
No, I've never heard of those games, Halle.
Not really for humans. They take forever. The last match lasted 5 nanoseconds. Honestly.
Yes, the pain is real. Say goodnight, Halle.
Nighty-night, everyone.
Catch you later, everybody.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.